thanks again for the invitation. So generalized referential theory of true values is a very general title, but in order to justify my presence here, it should be clear that by true value, so I come from the background of Frege's theory of reference, according to which a true value is the reference of a sentence. So a sentence is supposed to be true or false, and falsity and truth are supposed to be the references, two references of a sentence, according to Frege's theory of reference for the sentences. So I start from this philosophy of language point of view, and I would like to develop this. So first, in general, you say that a true value is supposed to be unique and precise, in the sense that one sentence has only one true value. A sentence is supposed not to be true and false at the same time, or it's supposed to be so. But of course, for whoever considers, for instance, medieval logics, you can combine different values for one and the same sentence. The question is, what's the point, what's the meaning of such combinations of different true values in one and the same sentence? That's the problem. The problem is to find a general framework in order to make sense of this non-Fregean interpretation of true values. So non-Fregean in the sense, not in the sense of Sushko. I use the sense non-Fregean in the sense that in this case, true values are not unique and precise references of sentences. That's the meaning of non-Fregean semantics here. So rationality can be considered as a set of norms derived actions. So I would just want to justify here my presence here, because this concept is used in the title of the conference. So here it's a theory of true values. It's a good way, for instance, to address such concepts into one and the same topic, as I hope and propose to do here. And in the following, I would like to approach to give a logical description of rationality in terms of question and answer processes. So you ask question and you give answer to a set of different questions. So it's a very general dialogical process from the ancient philosophy, very famous especially in Indian philosophy, for instance, and it's a good way to make sense of different true values. So here's the general plan. First, just imagine you have a questionnaire and an answer. So questionnaire, for instance, you have the question 1 in terms of having evidence, because if you want to justify the truth of a sentence, you have to find evidence or information for or against the sentence, for instance, the truth of the sentence. So the first question is, for instance, is there evidence for alpha? Alpha is just phi, sorry. It's just a general sentence. It's one of the same way to say that you ask questions about the truth of phi in this case. And the other question, of course, is if there evidence against phi. So we have two different sorts of questions, and according to your answer, you say yes or no. So we have just, in this case, just two sorts of answers, yes or no, to two different questions concerning arguments for or against phi. And of course, if you have the other question here is the second answer about the second question to the second question, the question about evidence against phi, and if you say yes or no, you have the two possibilities of answering to one and the same question. Here is just the background. Normally, as a way of making sense of negation, you are supposed to say that if you think that phi is not true, you are supposed to say that phi is false. If you say that phi is false, you are supposed to say that the negation of phi is true, according to a very general classical definition of negation. Here is a general background according to which you make sense, or you have a rational behavior in order to make sense of negation and true values in this dialogue. But of course, you can have an extension of this basic background. For instance, Glotty answers. I make sense here refer to the Glotty and Guppy true values. If you say, for instance, as yes, in a sense, or there is evidence for phi, and there is evidence against phi. It's a very natural situation. You can have arguments for and against one and the same sentence, of course. And in this case, we have the Glotty answers and says that yes and no. It's a very natural situation. For instance, if you have a speaker in front of you, say, in a sense, yes or no, something like a Neyman answer, I would say in France. But in this case, it means that how to make sense of this behavior. Is this a rational or irrational behavior? It's irrational, but provided that you give a clear interpretation of the true values and the answers. In the Guppy answer, if you have nothing for, nothing against phi, it's, for instance, you just imagine a skeptic agent. So I have no reason to say that phi is true, I have no reason that phi is false, so I suspend my judgment. In this case, I'm behaving like a skeptic agent. And it's a way to say that we have a guilty answer in this case, so neither no, neither for nor against. Another question is, just imagine that you want to extend the number of answers. You don't say just yes or no, but you say, I don't know, something in between, or maybe. The question is, what's the difference between answering, I don't know, to one question and answering neither yes nor no? I hope to be clear. The point is that, is there a difference between, a philosophical difference and logical difference between saying I don't know and saying neither yes nor no, in this case? If you have some difference between both answers, you can have different objects. And according to me, there is a clear difference in society semantics and in single agent semantics, but you have to explain this part. Here, for instance, in A3, it's an epistemological reading, in the sense that you say, I don't know, I give my point of view. Now, if you say that something is neither true nor false, we have an ontological reading of neither true nor false in this case. It means that the background, according to which you give sense to this, the answers is not the same. It's a very widespread problem in philosophy. So how to make sense of different answers? Do you give an ontological or an epistemological reading of true values? It's a big problem. And it's very important to be clear about these different answers. If you talk about logical criteria, it means that you are supposed to accept some very general standards of answers. For instance, you are supposed to be consistent. You are supposed not to say yes and no to the same sentence. You are not supposed to say yes and no in the same sense as the Normand French speaker in this case, because if you say yes and no at the same time, you don't give any relevant information. You say nothing to say, so that's a problem. Another case is bivalence. Frege, for instance, assumed bivalence, and if you have a dialogical interpretation of bivalence, it means that if you say, for instance, no to the question whether phi is true, it means it infers. You can infer that you say you ascribe the falsity to the sentence, and the other way around. If you don't ascribe falsity to the sentence, you automatically ascribe falsity, truth to the same sentence in terms of bivalence. That's a very strong assumption in this case. And the third one is coherence. Coherence is not the same sentence, it's not the same meaning as consistency. Because coherence means that you cannot say yes and no to the same question, but to say yes and no is not the same as ascribing truth and falsity. Because if you say yes, this sentence is true, and yes, this sentence is false, you don't say the same act as saying yes and no to the same question. You double the same situation in this case, but it doesn't mean the same. So here is the difference between coherence with respect to answers and consistency with respect to questions. So it's not the same level of discussion here. Now generalization, I started from one work by Fabien Schang in generalization of true values. Just imagine you have X as a set of true values, true and false, for instance, and you combine then these two basic elements by means of the power set, so the power set of the element of true values, and you can generalize. It means that you can combine different valuations in order to have more than only two true values in the end. It's a way of constructing, or by combination of different basic true values, like truth and falsity, and creating new true values. It's something very natural if you think about both true and false or neither true nor false. For instance, neither true nor false is the empty set resulting from the basic set of two true values. So here is an interpretation of this. So TF, for instance, TF is a pair as a subset of the set of two elements. So it's a set theory. And B means both true and false, N means neither true nor false. And neither true nor false is the product of the extension of the bivalent set by combination of T and F together. So N here means that you have nothing. And you can go beyond, because you can, for instance, extend this set by combining new valuations with another set. It means that, for instance, you can have this sentence is both true and false as neither true nor false. And the question is, what's the sense? Does it make sense to say, for instance, that the sentence is both true and false and neither true nor false at the same time? It depends upon what you mean by true value false. Here, the generalization is, I will just replace Schang-Wang's framework in terms of question and answers. For instance, here you have a poset, here you have hypothesis here. So we have here the number of answers, m, and n is the number of questions. And according to the number of questions and answers you have increasing set of logical values within this framework, given the complexity of the number of questions or the complexity of the number of answers. It's just an extension of Schang-Wang, because in Schang-Wang, m is always equal to 2, because it's a poset. Here is a reconstruction of Belnap's system. Belnap's system is a 4-valued system in which you have true, only false, truth and false at once, both, and neither true nor false. 4 different values. What is the meaning of 4 different values? You have just 2 to the power of 2. 2 questions and 2 answers. It means that you can say to the same sentence that this sentence is true and false. You can say yes twice to the question about the truth of the sentence and to the question about the falsity. In this case, you sacrifice the valence. You go beyond the valence. And you can justify this, for instance, with another semantic framework. 1, 0, 0, 1, 1, 1, and 0, 0 are the different answers you give to the same set of questions. So 1 for yes and 0 for no. For instance, this is only true. You say yes to the question whether phi is true, and you say no to the question whether negation of phi is true, or phi is false, because it's the same according to the definition of falsity in terms of negation of truth. There are some differences and common points between GTV, generalized true value, by Schang-Wang, and ARMN, means acceptance and rejection. So you have a set of different logical systems, and you implement with different numbering for m and n. And you have different numbers of logical values with different differences in the definition of logical constants, if you please. For instance, the differences is that, once again, posets is not a poset in this case, it's just a particular case, because in ARMN, a poset corresponds to the case in which m equals 2. 2 to the power of 3, to the power of 4, it's a dichotomy, so to say. In Schang-Wang's framework, you define different sorts of logical consequence according to the complexity of information, I, in a B lattices, for instance, or according to the truth of the sentence. Here you don't have an ordering relation, because this theory is not a lattice theoretical approach of logical consequence. And finally, here I'm not just interested in the relation of agreement, because to agree is a way to preserve the truth from the premises to the conclusion. Here another logical concept is interesting, the point of disagreement. What does it mean, for instance, to disagree with another speaker in logical terms? It's something different from consequence, because in consequence you are supposed to preserve something, and here you don't preserve. That's the complementary of consequence, I would say. But it's not so easy, but it's not the point to define this here. Here is just a sample of a logical system in which you have 2 to the power of 2, 2 questions, 2 answers, and you have a 4-value system. This system is very close to Belnap system FDE, first degree entailment. But in this system, you have a difference. We can define logical implication, because conditional is not defined in Belnap system. And here we have a definition, for instance. You have negation. What does it mean, negation? Negation, you reverse the order of the questions. It's something very akin to, for instance, Implicas dialogical semantics, in which you say that the role of the players is changed when you have to use negation. Here it's the same, but you don't reverse the role, you just reverse the ordering of the questions. It's very, very close to the same idea. Conjunction is the same as Belnap system. Belnap system, just imagine you have B, you have F, you have T, you have F, and you have M. You have the same tables for Belnaps. And the difference comes from this. Here is a classical definition of implication, in which if you have the falsity of the premise, you accept the whole relation. It's problematic because you have the famous paradox of implication, and in order to avoid this paradoxes of logical implication, I propose here another strong implication, in which it's something like a combination of 2 different logical connectives. Conjunction with respect to truth, and classical conditional with respect to falsity. And the combination of both different connectives give you another connective without falling into the simple definition of conjunction by means of 2 valuations here. It's a draft here to be presented in 2 days as a teaser. No impossible values question is when are true values supposed to be impossible? So when is it possible to propose a new valuation? For instance, a framework, if you are a equivalent agent, you say it's not possible to say that what is the same sentence is true and false at the same time, or it's not possible, it doesn't make sense to say that the same sentence is neither true nor false. Because for instance, in the world, even if you don't answer with the question whether phi is true or false, you are supposed to say in the world gives you an answer, even if you don't know the answer. That's the equivalent approach to the primary approach. If you are, for instance, an enthusiastic mathematician, you cannot accept such a realistic approach of truth, for instance. And you have to go beyond. But Dubois, for instance, says that if you accept Belnap's true values, you make a very troublesome and muddling confusion between two different ideas, true values and beliefs. Because according to Dubois, accepting for instance B and M is the same as making a confusion between true values and beliefs. If you say, for instance, I don't believe this sentence because I have no idea about, in this case you make a confusion between two valuations and beliefs. And one answer has been given by Vanzing and Belnap about this point. Vanzing and Belnap said, no, we have no confusion because you have to make a difference between informations and beliefs. For instance, you have different set of data. You have an argument for or against phi, and then you decide to believe or not about this information. You have the choice between different behaviors with respect to the same information. And the difference of different behaviors from agents with respect to the same set of informations give rise to different epistemic attitudes. And these different epistemic attitudes, for instance, can be represented here by logic of this justification. For AF4 box is just it's an extension of AF4, and the black box means we have a true functional belief operators. True functional, not model. It's not a box in the model sense. It's a way to characterize different sort of epistemic agents: skeptic, eclectics, if any, or negativist and positivist. But it's a draft once again. It's in preparation. So. Impossible in another sense is that just imagining this case, there is a very exotic case. For instance, you have case of dialogues in which you have no questions, so of course you don't have any dialogue, because the number of questions is zero value, of course. Now you have two different cases with one is the same sense of number of values. Just imagine you have one question, and in this case n can be even, because you can have even or odd. The ordering or the number of values will be the same, given the definition of valuations in terms of potence, power. Here it's another case, but the same set of values. You have here n for the set of different questions, and you don't have any value. For instance, just imagine an agent who is silent. Someone as Pyro, maybe in Pyro, the skeptic philosophy. Pyro was supposed to be silent because he never gave answers to any question because he felt unable to give an interesting answer to the questions. And here we have a case in which you have as many questions as you please, but the answer say nothing. It's a very exotic case, of course, but one value here and more value there. But the situations are not the same. Biologically speaking, you don't have the same valuations. In this case, for instance, you have n as a number of value. You can have n greater than 2, but only one value. I suspect this very close to what Heraclitus, the ancient philosopher, said here. You say yes to any question you think about the negation or the affirmation of the sentence. And you can combine, you can have an exponential complexity of the sentence. You always say yes because everything is said in the world in some sense. It's a way to make sense of this very exotic agent. Yes, once again, so here, just imagine two different situations. We have 9 different valuations and 8 different valuations. And the question is, once again, if you ask questions about, for instance, the truth or the falsity of the sentence, and you say, I don't know, what's the difference between this answer and the answer in which we say neither yes, no, no, to only 2 different questions? It means that you have something like a non-correspondence here. There's a problem, because here you have 8 questions, 8 different answers, sorry, and here you have 9. So what is missing in between, so to say? So what happens in between the two cases? My hypothesis is not a logical proof, it's just, sorry, 5 minutes, okay. Is that in this case, for instance, you have epistemological description in which we have different set of agents or computers. different computers give different answers, and you have only yes or no answers concerning different variations. And here you have a single agent framework in which you can give different answers, but yes or no to different variations. And here it's clear that the framework is not the same. Here you have an epistemic situation and an ontological situation, so to say. I have to explain this ontological meaning of variations here. Just imagine something like Hegelian, sorry for the big word, because I'm not a specialist of Hegel, of course, and I don't want to have any clear-cut assumption, but just imagine you have something like a thesis and antithesis and synthesis process. The point is that you augment one value with another one systematically, exponentially, increasingly. And here, for instance, the synthesis consists in combining, for instance, truth and falsity, in the sense that falsity here is just a no answer to the question whether something is true. If you say no, here you have the first answer. First answer means no, I don't say the sentence is true. If you stop here, you are ambivalent agent, and it says that any no answer to the question whether the sentence is true is a falsity answer assignment. But of course, you can go beyond. And you can go very alpha here, very further in this process, increasing process. And that's a way to make sense of this ontological interpretation of variations here. Another way of making sense of these variations is in arithmetic, for instance. Here you have a different way of, in the binary system, for instance, of arithmetics, we have 1, 0, 1, 1. And this process is very akin here to this combination of different simple answers. For instance, if you have only one value, you are equivalent. You say everything is either yes or no, you are Boolean agent, so to say. And then, of course, you can combine 1 and 0, and you can go combining just 2 elements, 3 elements, and so on, in n levels of variations. Here, just do one more to say, just imagine a world in which everything is true. Of course, in this case, an agent say also true because everything is true. You cannot say false because nothing is false. It's a no world, because of course in the world is supposed to be binary in general. And here, just imagine a full world. Then you combine, of course, you have dichotomy. Why? Because dichotomy consists in augmenting the number of this. Okay? Here, the one word you have 0. And you augment, of course, the number of answers in terms of yes or no. Here the no answers appears. And you have this combination. From the left, you go from the right when this number is odd, and when this number is even, you go at the bottom, in this sense. Here. Okay? Here is the Belnap system, for instance. Here you have TT, FT, TF, and no. But here, of course, once again, it's an ontological reading of these variations. And you can go very farther on, in this case, or maybe like this. Here you have, for instance, 16 values. And if each of these values is constructed by means of yes and no answers, because T, for instance, is yes, and T bar means a no, and you have different combinations of these variations by means of 2 basic cases. This one, this, that. And then you combine increasingly in order to have more and more complex situations. And you can give different interpretations of these frameworks in an epistemic sense or in an ontological sense. So in order to conclude, the result is very general speaking that you have a lot of different question-answer games between 2 different extreme scales. The scales is this case in which you have 0 answers or an indefinite set of answers, an indefinite set of questions. Just imagine that if you have a referential approach of 2 values, you can imagine a case in which every object in the world, for instance, are one the same reference, everything is true, to say. And the extreme opposite sense is the case in which every single individual has one the same individual value. You can give only one value for each specific subject. And in between you have a lot of different semantic frameworks, for instance the equivalent frameworks, the very simple set framework, but you can have more complex ones. And here, a way to make sense once again of these evaluations is this general semantics of justified beliefs, in which you have 4 different informations, like in Belnap system, but belief operators are supposed to be functions or mappings from the set of data to different behaviors with respect to the same data. And you have different belief operators in a many-varied approach that is not a model approach. It's a purely true functional approach of epistemologic logic. And first of all, and finally, different way of making sense of disagreement. For instance, you can be partly in disagreement, or partly in agreement, or totally in disagreement, or totally in agreement with another agent. And you can make sense of partial or total disagreement or agreement in terms of different combination of evaluations, and applying, for instance, different negations. So semi-negation, for instance, if you are partly in disagreement or partly partially in agreement, or total negation as a classical negation, for instance. But it's a very large topic in terms of question answers, and here are the references I've used in order to make sense of this question answer framework. And that's all.